So this factoring sheet that you've got in front of you, the green one, should look familiar because I've handed this out, I know, at least twice this year. So some of you may be getting quite the collection of these at this point. So what we're going to be trying to do as we're going along with these is just remind ourselves of our rules that we're going to be doing as we go through this. So I will come back to the factoring breakdown sheet in a minute. Well, actually, let's chat about this for a second. Okay, numero uno, and it's number one for a reason. Our golden rule. The golden rule is when I look at a problem, is there anything in common that I have to factor out? Because if there is, A, that can make my life easier, and B, in some cases, it may make it where I can actually factor it. So again, I've got an example on here. If I see something that has, if they have something in common, let's say, like they do 5 there, I got to take that out and then see if I can factor what's left. Okay? Once I've passed that by, then I look to see, okay, what else can I do to it? You know, are they perfect squares? Now again, are they perfect squares? Reminder. And I'll just go to 10 here. If you see those values and there's only 2 terms there, probably it's going to be a difference of squares. Where I look and I say, okay, what do I square to get my first term? So like here, that'd be 3x. What do I square to get my second term? So for instance here, that would be 7. And then I just put the plus and minus in between them. Okay, if they're not perfect squares once I take it out, it may just be the common factor, and that's all I can do. But there is one part we added last time that I did not put on my breakdown sheet, so we probably need to add this. We talked about perfect squares here. Well, what about if they are perfect cubes? Okay, so we have played with that before. So, okay, reminder, what's that mean? What would that look like? Well, that would look, so if I have something cubed, we'll get to a numeric one here in a little bit. But if I have 2 numbers that are cubed with a plus in the middle, because I can have either, there was a pattern to this. And that pattern was, I'd add the individual pieces first, so A plus B. And then there was a big set of parentheses on the second part. And I'd square my first term, switch my sign. So if I started with plus, this one would always be minus. And I'd take that product, and then I'd add the square of my last term. So it was square it, times them together, square the last one. It was sort of like a pattern that you were following along to get that up there. And I'd have the same type of pattern if I had a difference of cubes. The only difference, no pun intended, if it's a difference of cubes, is that my first quantity, my first set of parentheses would be minus, and then when I got to my product in this second part, the sign switch would make it plus. And like I said, we're going to be looking at several examples of something like this, so we should be able to get back into the swing of things and how this works. But that pattern would be something that's definitely helpful moving forward. But again, that's if I have 2 terms. Okay, because we haven't gotten to the big ones here yet. The big ones are the ones we've actually had the most experience with. So I figured that'll probably take us the least time to chat about. I'm going to scooch this up a little bit just so we can get to that bottom part. There we go. Okay, so if there's 3 terms, still look to see if there's anything in common. If there's no number in front of the x squared at that point, we just do the diamond. And again, the diamond is just multiply 2 numbers to get the number on the end, add to get the 2 numbers in the middle. And then if there's a number in front of x squared, okay, we can slide and divide or we can guess and check. Now, I actually want to take this one that's on here and chat for a minute on how we could do either of those. So I'm going to talk about the guess and check part first with this one. So if I was going to do guess and check, I can't do what multiplies to negative 20 and adds to 11. That doesn't work once there's a number in front. So what my job would be at this point would be to take my 3 and I'd try to figure out, okay, what numbers can multiply to get 3? Well, I don't have many choices now, do I? So I'd take my 3 and I'd say, okay, well, it could be 3 and 1, or it could be 1 and 3. And I'm going to write both ways that I could write that, and you'll see why in just a second. And then I take my number on the end, the minus 20, and I'm going to come up with the different combinations that could be. Now, this list is going to take a little bit because there's a lot of numbers that can multiply to get 20. So I'm like, yeah, now if I start, I'm like, okay, if I start with 20, so negative 20 and 1, negative 1 and 20. And if I just kind of work my way up the list, I'm like, negative 2 and 10, negative 10 and 2, 3, no, 4, yeah, negative 4 and 5, negative 5 and 4, but that covers it. And so if I get to this, what I would attempt to do at that point is to find myself the pair that when I multiply the pairs together, that I could get 11 in the middle. So here's how that would work. So maybe I start and I go, okay, I'm going to use 3 and 1. And I'm just going to work my way down this list. Now remember, I'm trying to get 11. 3 times negative 20 is negative 60. Okay, this isn't going to work. It's negative 60 and 1. No. Negative 3 and 20. No. Negative 6 and 10. No. Negative 30 and 2. No. Negative 12 and 5. Ooh, we're getting closer, though. No. Negative 15 and 4. Okay, that didn't work real well. What the heck? And so I would just have to go through and keep looking at my combos until I got to a pair somewhere along the way. And I'm going to cheat a little bit here, because it actually ends up being like almost the last pair that I have. I'm like negative 4 and 15. Ooh, wait, negative 4 and 15. Okay, so what does that mean? It means as I'm doing this, the 3 goes with my 5. I'd write it down. And these go together. So I'd have 3x and the minus 4, because I'd have 4 and 15. Oops, my pen is dying. Okay, to get to 11. Now again, it's a comfort thing. I know some of you can do all the mental math and kind of play with it that way and have it work well. But if that's not your style, you're like, yeah, I get to that much guess and check, I'm just going to kind of shut it down. Okay, here's your other option. I'd actually have you flip over to the back here because we might run out of room otherwise. So if I take that same problem, and a lot of you have become more comfortable with this, and this is fine, it still gets me to the right answer. So at this point, we'd go to slide and divide. So if you remember, slide and divide is when I take whatever that value is at the front, and I slide or multiply it down to the end. At this point, my problem becomes like a diamond, where I'm trying to multiply to get the number on the end and add to get the number in the middle. Now, there's still going to be some guess and check to this, because if I don't know off the top of my head what multiplies to negative 60 and adds to 11, okay, I may have to mess with some numbers in the calculator, but always look for those clues that we've talked about before. If it multiplies to a negative, I know one's a positive and one's a negative. I also know that the bigger number has to be the positive, so the add number works. So I go to 60, and maybe I don't know, so I just start typing into the calculator, and I start small, and I go, okay, 1 goes into 61, so that doesn't help me. 2 is 30. Nope. 3 and 20. Nope. Because they got to be 11 apart here, or so we think. 4 and 15. Ooh. 4 and 15 are 11 apart. Wonder if this would work. Okay. If I put the 15 here and the 4 here, does this work? Negative 4 plus 15 is 11. That works. 15 times negative 4 is negative 60. Okay, cool. Here's the danger, though, with slide and divide. A lot of times people get this far, and then they're like, good, that's factored, I'm done, and they go on to the next problem. Well, here's your issue. This doesn't FOIL out to this, and that's what I need. FOILs out. Yeah, we got to remember the divide part. Whatever that number is that I slid down, I've got to put that back into the problem. So, right. If it goes in nice, 15 divided by 3 is 5. I can do that. Exactly. If it doesn't go in nice and the fraction is completely reduced, okay? If I could reduce this fraction, I need to do that still, but I can't. That value that I had there goes back to the front, and it's factored. Okay? For some of you that like diamond problems and can deal with those but just can't deal with the guess and check as easy, this is your option. Okay? There aren't a ton of options. It's slide and divide or guess and check. So, something to consider. Okay? But again, you'll have this sheet. The nice thing about this is whenever you're doing factoring stuff, if you keep this by you, you're always going to have that way to kind of say, oh yeah, that's how this works. Oh yeah. I still have to do this, but it's at least not quite as bad. And that basically covers everything we're looking at factoring-wise, except for the one exception of I didn't write any perfect cubes down. So let's jot a few of them down here that you may run into. Why did I just go brain dead? Because I wrote the wrong numbers, that's why. Okay. That's scary when you get 125. I messed up over here. I got ahead of myself. I think that's as far as we're going to end up going, so that's as far as I'll write here. So, yeah, I was going to say that's 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, and 7 cubed. So again, this is your ultimate assist sheet. The only bit. I'll get back to you on that. Instead of putting myself on video forever with evidence, I'm learning quickly not to put anything in evidence. So I'm not going to say yes yet, but...
Is there a high possibility?
Yes, we'll look at it that way. Yes, there's a high possibility. Okay. So let me move this out of the way for right now. Why I put out the blank sheet of paper for some of you was in case you did not have like a notebook or notebook paper or something, I wanted to have some practice problems, like some notes that you'd have to be able to kind of see how all these different things work when you're working on your worksheet for this. So we're going to take a look at some of the situations that you can run into and make sure we're in good shape with this moving forward. So I look at number 1. And on every single one of these, you have to do this. Is there anything in common that both of those terms have? Is anything divisible into 2 and 18? 2, okay. Do they both have a variable? Yes, okay. We're always going to take the one, if they have something in common, we're going to take the one with the smaller exponent. Okay, so we're going to take 2x squared out. Once I've taken that out, we're going to go ahead. And so as we're taking a peek at this, now my question becomes, what do I have to times this by to get back to this? Well, I've already got the 2. Now, if I want to put a number in there, I suppose I could put a 1, because 2 times 1 is 2. But remember your exponent rules. When we're multiplying, yeah, we're adding exponents. So 2 plus what gets me to 5? That would be 3. Okay. 2 times what gets me to 18? And I've already got x squared, so I don't need any other ones. And in this case, that's all I can do. Because if I look at this, I'm like, ooh, x cubed, but, well, wait a minute, 9 isn't a perfect cube. So if that would have been like 27 or 8 or something like that, I'd have been able to do some more. And sometimes that's going to happen. But again, it's just got to be a comfort level that you kind of practice and get used to it. The next one I look, do all three of those terms have anything in common? True, they all be divisible by 1, but that's not going to change much. Otherwise, no, okay? 2 of the terms have an x, but it's got to be all of them for me to be able to take something out. So I look, and I'm like, ooh, it must be a diamond problem. So we're looking for 2 numbers that multiply to negative 24. There you go. That means you've got 1 of each, and the bigger number is going to be the positive. And so 2 numbers that are 2 apart, 4 and 6. And I can just double check. Negative 4, positive 6 gets me positive 2. I'm good with that. But again, it's all a process. It's all just kind of getting used to what can happen on these. Okay, 3. Now we'll start getting a little more interesting. Anything in common? Anything that's divisible into both of those? 2, okay. So if I take out the 2, okay, 2 times 4 would get me to 8. 2 times 25 would get me to 50. And then before you circle it and say, woo, that's done. Yes. I look and I'm like, wait a minute, there's only 2 terms there. Wait, I've seen those numbers somewhere before. Oh, 4 and 25. Oh, they're perfect squares. Okay. So the 2's still going to be there. Okay. What do I square to get 4? 2. And again, the x is with it, so I get that in there. What do I square to get 25? 5. And it's always going to be plus minus, because I want to get negative 25. Now it's done. So we've already seen just in this first handful of problems, okay, sometimes I'm just going to be able to take out something that's in common. Other times I'm literally, once I do that, going to have to factor whatever's left. And again, it only comes with experience. It only comes with practice on getting how that's going to work. So again, as we move down here, now this time I look at 4 and I go, okay, I can't take anything out right. I either have got to start working it like we talked about before, where I make my 2 lists of numbers and I start just playing with them, mental math wise, or my other option would be, again, to play the slide and divide game, which is not a bad thing. So I'm like, okay. Again, let's look for clues that we have to try and make this a little easier on us. I notice my multiply number is a negative, so that's 1 of each. I notice that my add number is positive, which means that's going to be the bigger value. So 2 numbers multiplied to 72 that are 1 apart, 9 and 8. But again, reminder, slide and divide, not just slide. That's 6. Okay, and this is going to be what I was talking about before. Because you may be like, okay, 6 doesn't go evenly into 9, so I'm just going to put the 6 back in front.
No, they're both divisible.
Nice, okay. If you're not sure, go ahead and get that in there, but you always have to reduce the fractions if you can. Okay, so even if some little thing like they're just divisible by 2, once they're simplified, then you're ready to swing that back to the front and have your solution. And again, guess and check works here, the slide and divide works here. It just depends on your level of comfort with things. But you have to kind of be able to play with those. If you need to make a list like we had before, that's okay. You can make a list. Calculator makes it real quick to do that. I think I got a couple more here on the back. Okay. I'm going to skip my number 5 and go to my number 6 here. So I have not forgotten how to number. All right. First question on the golden rule. Anything in common? 2. Okay, so I'm going to get that 2 out of there. And more times than not, if there's 3 terms, it's probably going to factor. All right. Let's see here. Or is this one going to? Because I look, I'm like, okay, if this is plus, that means they're either both positive or both negative. They'd be both negative. But wait a minute. Can I multiply 2 numbers that multiply to 10 and add up to 3? Because you're like, well, 5 and 2. Yeah, but if I do 5 and 2, negative 5 and negative 2 add up to negative 7. So in this case, that's it. So don't think, again, try everything. I mean, if you sit there and you're like, well, 10's got to be 1 and 10 or 2 and 5, but I know they both have to be negative, bless you. Oh, well, if they have to add up negative and negative, yeah, that doesn't work. Then it doesn't work. Just something to consider. But again, always take that value out at the start to make sure. So I get down to 7. I'm like, okay. Nothing in common, yes, but they are. That cube tells me to look. Hey, they're perfect cubes. Oops. Hey, they're perfect cubes. So here's how I normally will tackle these. What do I cube to get 8? 2. So I'm just going to write down, okay, 2 and x. What do I cube to get 125? 5. Okay, so here's how this works. Make my couple sets of parentheses here. My first set's always just going to be those 2 factors with whatever sign in the middle you had in the original problem. So I started with plus. I'm going to use plus. And this is where having my little pattern is going to help me in this case. Let's see if I can move this down and get this to fit. Because what we're going to do... Nice. Okay. So we're doing sum of squares. There's my a plus b, those guys. I'm squaring my first term. So I'm squaring the 2 and the x. My sign changes. So I started with plus. Now I'm going to do minus. I multiply these 2 guys together. So 2x times 5 would be 10x. And then I square my last term, and 5 squared is 25. And the nice thing is that'll never do anything more. Once I follow the pattern, I'm done. Which makes me a much happier camper personally. Okay. Last one. Anything in common? 2. Okay, so I take the 2 out. And again, if you're not sure 2 times what gets you to 54, you can actually run this backwards. You can say, hey, this number divided by this will tell me the value. And in this case, it tells me it's 27. So, can I do anything else? Can I do anything with x cubed minus 27?
Yes.
Yes. Because what number's in front of that x cubed when I don't see one? I have a difference of cubes. So, I leave the 2 alone. Now remember, and I wish I'd have done this a little bit differently, but we're going to make this work. Whatever I cube to get x cubed, which would be x, that's going to be my first term. And whatever I cube to get 27 is my second. Notice I didn't take the negative with it. The pluses and minuses all work themselves out in the formula. I just want the numbers. or in this case, the variable it goes with. And since it's minus, okay, I'm going to follow this. So x, there's my minus, so x minus 3. Then I square my first term, change my sign, multiply them together, and then square my last term. So, your job in this is going to be tackling the Factoring Revisited worksheet, which will have a nice combination of all of these different types of things for you to play with. There is a key up front. And tomorrow we're going to start working this into, okay, why do we need to have all this factoring stuff to do? You will start seeing in a very real way tomorrow why that is. But again, give it a shot, try a few out. We'll discuss this some more tomorrow.